figure out what you're going to, there we go, what you're going to make. So let me, hold on, let me do it 10, where's my pen? There, let me do my 10 minutes real quick. It's weird because if you go in Miss Castleberry's room, which is right around the corner, it's like 10 degrees hotter. Like it's warm over there. It's sort of like in between. I don't know why this room is so dang cold, but it just is. I see Declan. I see Caitlin. I see Luke. Luke and Sebastian. This is Slate. Give me just a second. Let me do the attendance and we will get started. I don't have the slightest clue anymore. It's so many people have been quarantined that like it's just nuts. Okay, now these people may just not be on yet. Okay, so in person, we got Jared. I don't see Brianna. Caitlin's online. Slate's online. Sahara, Tiffany, Lucas. Here. Tatiana. No, I don't see this one yet. Okay, I don't see Bailey. Kyle. I don't see Matthew. I don't see Robert. Aiden. I don't see Veronica. Nope, Veronica's online. Valerie is online. Mia, Reagan. I see Jeremiah. Okay. And I probably have people while I went through that list. I will double check. I'll double check when I go through this. But our opener, let me turn the light off. How do you determine the charge of a metal that needs a Roman numeral? For example, this chromium and hydroxide compound. All right, so when you have a metal that needs a Roman numeral, you have to figure out how positive that is. The way that you do that is you take a look at the negative side of the compound. And don't forget the polyatomic ion thing, the quiz on Friday is the last two groups. One of them is actually acids, group 5 and 6. And I'm going to have to write on the board because we all know my start board. Well, let me write on it. So on the board, I have CR in parentheses OH. And then a 3. I know that this thing in parentheses is on this chart. If they're in parentheses and there's a number outside, but you're going to get it from here. So I need to find the hydroxide, which is right. It's in group 2. Each hydroxide has a -1 charge. So I'm gonna work out the negative side and then reverse it to the positive side. Each hydroxide is -1, but how many of them do we have? How many hydroxides do you have? 3 of them. What's -1 times 3? You see -4, you see -3. Oh, I thought I heard 4. I was like, no. That means to the right-hand side of the squiggly line that I put between the chromium and the hydroxide, -3. The left side then has to be opposite, which is +3. So to figure out the chromium, you take your total positive charge and you divide it by how many? And is there a subscript for the chromium? No. No. So it's going to have to carry the full positive charge. I used to show people how to do this by reverse crossing. You never make a mistake if you do it this way. If you reverse cross, and a lot of times that works. And if I do this one on the board, do both of these. It works for this one. What I did, for those of you that are online, I wrote down Fe2O3, and I literally took the subscripts, reversed them up for the positive and negative charge, and it does work. It does work for this one because oxygen is -2. However, for the one that I did above it, the FeO, that does not work. They're understood to be 1, but oxygen is not -1, it is -2. So this is a situation where the reverse does not, well, when it does work and when it doesn't. But the way that I showed you, you know the negative charge, you multiply that by how many you have, that's going to then become your positive charge, you divide that by how many of the positive ions you have, that always works. And I don't want to show you too many different ways. I mean, if you do reverse cross them and your negative charge is the correct charge, then you've done it correctly. In the example with the one with the oxygen, I reversed it. Oxygen's not -1, so that will not work. All right. This is something. Do what? Okay, so the way that you determine it is basically what I did on the board. You're going to know, you guys can't let me unfreeze. You're going to know the negative charge. In this case, hydroxide's -1. However many you have, which is 3, times its negative charge. 3 times -1 was -3. The positive side is going to be opposite that, so +3. But you only have 1 chromium, so you divide how many of the atom is into the total positive charge. This is really, I mean, technically this is math, technically, but it's not anything like what we're going to be doing next semester. Now, you guys have in Canvas this link. I need to share the way I need to stop the way this is being shared. Hold on, guys. I got to share my entire screen, and I have people that have come online. So I really left my pen over there at the door. Okay, so Alexis is here. And I'll double check. I'll double check again. Okay. So when you guys click on this roll the dice virtual lab mixed ionic compounds, no, we're working on stuff. And I printed this out. Okay, so for those of you that are in person, you still need the dice. Okay, so go ahead and open this up. And it says to click this link for digital dice, classroom dice. And then it goes on to say that you need to, I think it's just the pink and blue dice. When you open up the dice, you guys originally have 3 dice. You do not want this yellow one. You don't want this yellow one. So that when you roll the dice, oops. Wait. Okay. Well, that was weird because I had it the other way. Anyways, you're going to hit the toggle so that you're only going to get a pink and a blue dice. You just re-roll it since we're not allowed to touch things. And then if I go back to here, roll the dice, and then using the key below, record the positive ion. Okay, the blue, so if I go back to my dice, the blue is a 3. So that means you guys are all going to have different things, which is nice with this. It's just random. So my 3 is iron +3. It's not necessarily yours. And then my negative ion is a 2. So in this case, that's going to be phosphate, PO4 with a -3. So you're going to, and like I said, everybody's just going to be different. You're going to do 10 of them. Whatever your dice says your positive is, whatever your dice says the negative is, if they add to 0, because these didn't, +3 and -1 did not add to 0, you crisscross them. And then you need to name them. Nickel does need a Roman numeral. That is probably going to be the trickiest part about this is, does this thing need a Roman numeral or not? So if I go up here with your metal ions, the iron does need, well, you guys don't have nickel as one of the one that's on here. The only one up here that needs a Roman numeral is this guy, the iron. If you get iron, if you roll a 3 like I did, you can't say it's iron because it was Fe plus 3. And then it was what? PO4 minus 3. Isn't that what I rolled? I don't even remember what I rolled. 2 and a 3. 2 was the phosphate. 1 was magnesium. And then you can, it says you can use the control and then the side arrows. I just use control and either period or control. Control period makes a superscript. Control comma makes a subscript. In this case, in mine, I forgot to make my 4 subscript. Because plus 3 minus 3 add to 0. Yeah, so I don't even need parentheses. It's FePO4, and that would be, in my case, that is iron 3 phosphate. That's not necessarily what y'all are going to have because it's all randomized by these dice. Let me go back to here. Yeah, there's paper one right here. But like I said, you're going to need the digital dice. We all want the paper version to write stuff out on? You can do it online. And then you just go and you scan it. Yes, if you have other things that are naming, I dumped a whole bunch of grades into the grade book, like 5 of them yesterday. And obviously, if you're still turning in some of these naming ones, I have to grade them and get them in. It takes me a while to hand grade them. And then I will put them into Parent Portal. Okay, so did anybody else want a paper version of that? We pass all these out, and I'm going to double check. Anybody else, do you want the actual paper version? The exact same thing. And everybody else. All right, so let me turn the light on. Now what happens? What happens?
What?
Somebody blew the fuse. Okay, I need to go downstairs. The thing that runs my projector, the breaker just snapped. I know where it is though. I'll be back in just a second.
Zero in. How did you miss? Not bad. Not. Do that. Okay. He's bored. Yeah, looking more. You can make sure you face. What? You can show your face first.
Oh.
And then like 30 minutes to see it. And it's sick. I tried. I couldn't see.
Same. I was watching YouTube online.
It was like it's sick. That's the thing. What do you say, baby? No, what did you say? Okay.
All right, so give me a second and let that. Sorry, that's not. Turn it on. At least I know where the breaker box is when it goes. All right, so sorry online, my projector just went out. All right, so let's see, where were we? Let me double check the online one more time. Turn lines here. Okay, so that was just a fun little field trip I had to do. All right, so once again, I know for those of you that are remote, I haven't printed off, but that doesn't, I had an itch. I swear, all the time, I had an itch. All right, so the, in Canvas, right here we go, the assignment, and you have to click on this link to get your dice. Other than that, I mean, I guess if you had real dice at home, you could throw real dice, but you need to toggle these around so that only however it is that it needs to be done. Like, I don't want the yellow dice. And I want the pink and blue. Okay, when you roll your dice, everything's going to be randomized. This one, the blue was a 3, and then the pink was a 6, and you go back into here. And I'd say that was a 3. So the same thing. It's that iron plus 3. But in this case, the second time I did it, the 6 was the sulfate ion. And you're going to list your ions. Control and period or control and comma is going to switch it back and forth between superscripts and subscripts. You're going to list your ions. You're going to write the formula, crisscross if you have to, and then you're going to name it. And once again, the only one that needs a Roman numeral is that iron if you throw a blue 3. Once you are done with this, then it says explain what a positive ion means. Now you need to be talking about electron specifically. What does it mean if it's positive? What does it mean if it's negative? It says explain why ionic compounds are fixed in their chemical composition. That means why are they in certain numbers? Like why are we doing that? Why do some of them have Roman numerals? And then if an element combines with oxygen to form an ionic compound of X2O, we want to know what the charge of element X is. There's not an element X up there. There's an XE, but that's not what this is talking about. And really, you should be able to finish this in class. The other thing that y'all should be doing, if you had not, was all of those nomenclature things. I think here, the binary ionic naming. I can't remember what my due dates were. Yeah, the one from Monday is still open through midnight through digital submission. Now let me stop this. Stop the recording. And then for those of you that are online, do you